Okay, this is part 2, so you should have just done questions 9 through 12. Now we're going to go ahead and graph y equals 3 to the power of x. I want you to see what this looks like, and I want you to know how to actually fill in the y values when you're given an x value, because you're going to see a lot of questions like this in the content assessment. So let's start off easy. If you go ahead and plug in 2 for the x, and you raise 3 to the power of 2, 3 to the power of 2, 3 times 3 is going to be 9. 3 to the power of 1 is 3. 3 to the power of 0 is 1. 3 to the power of negative 1 is going to be 1 over 3. 3 to the power of negative 2 is 1 over 9. And if you graph this, I can't show you what it looks like on this graph, but what I can do is go to Desmos and talk you through what you should see. Y equals 3 to the power of x. Now notice that we have this exponential growth happening here, and you'll see that if you follow along to the left, this red line looks like it's touching the x-axis. However, it's never touching the x-axis, because what's happening is the higher that exponent gets, that's negative. So like if the exponent was negative 5 versus negative 10, your fraction is going to be smaller and smaller and smaller. It's going to be like 1 over 256, 1 over 548. And you're never ever going to get 0. So think about like tearing a piece of paper in half. If you tear it in half again, you're dividing it in half, divide, divide. You're never going to have like no paper. You're still going to have a little bit of paper left. You're never just going to have nothing. So think about that when you raise a whole number or a fraction to the power of a negative number. You're never ever going to touch the x-axis. And watch, you can zoom in. Do you see? You're never touching the x-axis. It's never going to get like right on the x-axis. It's going to get really, really close. Like your y value is going to be really, really small, but your y value is never going to be 0. So if you want to go ahead and plot those points, you could sketch it in this example right here. I want to move this along to the next question. This one's different. So this is y equals 1/2 to the power of x. 1/2 to the power of 2 would be 1/2 times 1/2, so that's going to be 1/4. 1/2 to the power of 1 would just be 1/2. 1/2 to the power of 0 is 1. 1/2 to the power of negative 1, so that's going to be 1 over 0.5 to the power of 1, which is just 0.5. So that means it's 1 divided by 1/2. Well, 1 divided by 1/2 is actually equal to 2. And 1/2 to the power of negative 2 is actually going to equal 4. So see if you can identify the pattern that's happening here. So notice that our starting value, or I shouldn't say our starting value, our grow by number, our growth factor is 1/2. And so it's kind of like taking Miss Colacino's paycheck and cutting it in half, and then the next year gets cut in half again, the next year gets cut in half again, or maybe I should say the next month. So you're actually decreasing. So when we graph y equals 1/2 to the power of x, you'll notice that we get a decreasing function. Okay, that's because 1 over 2, you're dividing by 2. You keep cutting in half, so you're actually decaying. And again, it's never going to touch the x-axis. So you never have a y value of 0. You're going to get really close to 0, but not get 0. Okay, so what I would recommend is actually going ahead and graphing that and then seeing what that looks like, because that's going to be really, really helpful for the content assessment. What I would like you to do next is graph 2 to the power of x and 1/3 to the power of x. So pause this video, go ahead and do that. Okay, now you should unpause me and you should be down here at these notes. My intention is that as you're in my workshop, I'm going to be checking your work, so I will give you feedback on questions 13 and 14. Let's go ahead and move along to the vocabulary. This word right here, asymptote. Ooh, what a hard word. It is a hard word to say. I want you to see what comes up in Google Image when you Google that word. An asymptote. Oh wait, you can't hear that. Here we go.
Asymptote.
Asymptote. What a weird word.
Asymptote.
Asymptote. You'll see if you click on Google Image, it's like that tail part of the curve. It's like when the curve of an exponential function gets straight. So typically, at least in algebra, 9th grade algebra, your asymptote will be at the x-axis. It's going to be that horizontal line. Okay, basic exponential functions have an asymptote at the x-axis. All right, last but not least, the second vocabulary word is x-intercept. So basic exponential functions never, ever touch the x-axis. So basic exponential functions do not have an x-intercept. So when y is 0, when x is 0, y will be higher than 0. You won't actually touch the x-axis, therefore you can't have an x-intercept. All right, the last part. Exponential growth always, I hope you know what this is, what this blank is. Before we fill in the blank, let me reformat that. There we go. Look at this picture. Okay, so if we zoom this picture out, actually let's zoom in. Look at the zoomed in picture. You see how that red line is straight and it's going up at a constant rate, and then this green line is actually starting lower than the red, and you would think, okay, the y values are lower than these y values. So green is lower than red, or exponential is not growing as fast as the red line is, as the linear line. However, if you zoom out, look at that. Ha-ha! The geometric growth, aka the exponential function, is surpassing the red linear line that is growing arithmetically. So no matter what, like eventually you have exponential growth. Exponential growth will always, always exceed linear growth. Go ahead and fill that in. Exponential growth will always exceed linear growth. And what you should do now is you should try to answer questions 1, 2, and this should say question 3. Okay, so go ahead and pause and try those 3 questions. Ready, set, pause. Okay, so hopefully you did those 3 questions. I'm not going to give you the answers in this screencast. I'm going to ask that you raise your hand, you call me over, and you show me what you answered for questions 1, 2, and 3. Then what you're going to do is take the diagnostic if you haven't taken it recently, and then you are going to attempt the content assessment if you take the diagnostic and do pretty well. So again, this is the end of the screencast. You are now going to finish this in real time, and I'm walking around helping you. So hopefully this was helpful. Let me know if you have questions.